This is the second design, which called common collector. As I mentioned before, this one is used to actually provide current AI, but for the voltage, it is not giving you amplification. Okay, but it doesn't have inversion. So the relation between input and output, there is no negative sign. This is how the signal look like. So the input still at the base, but the output is across this RL. So it is as the emitter side. It's not as a collector side. And you have two capacitors here, CN and C out. Okay. So this is a circuit that's equivalent to it. You replace the transistor with the AC model. So now let's relate this RP, little RE, little whatever here to the real resistors. According to this, okay, RP and capital RB are the same. There's no difference. This RP and RP are the same. Okay. There is another model when we have a voltage or resistor across the generator. This is the one in the book. But if we assume that this R generator is very small, there's no very small resistor for the generator, then we can use this one here. So I'm using this one just for simplification. In this case, RP will be the same like this capital RP. Okay. What about RE prime? No, RE prime, we get it from here. 26 millivolt over IC. And how do you get IC? IC, you get it from this loop again. Okay, so this VEE is equal to this current IP time RP plus 0.7 volt plus IC time RE. And you know that IP is IC divided by beta. Okay, so this is IC and how you get RE prime. What about RE? RE in this case, okay, is that when this one is AC, then the capacitor short circuit. Okay, then the resistance between these two terminals here equal what? Equal RL parallel with RE. RL parallel with RE. So this little RE equal RE parallel with RL, and little RP equal capital RP. So this is a model for this amplifier. So now let's see the parameters. First, we need to find the gain, then the input impedance, then the output impedance, exactly like what we did before. So what is the gain? The voltage gain, AV, is the ratio between V out and Vn. V out is here, this V out here. So according to this, V out is the voltage across this RE. So of course it will be this current time RE, which is IC time RE, little RE. So what is the input voltage? The input voltage is this Vn. And Vn, I don't know Vn, but I know that Vn is Vb because it's the same node here. All these are connected, so it is Vb. So V out over Vb. What is Vb? Vb equal what? Equal the voltage across these two resistors. Okay, so it will be IC time what? Time RE prime plus RE. Okay, so here's again AV equal V out over Vn. Okay, so it is VE, this one here, over this VB. The voltage V out equal IC time RE, little RE. And VB equal what? Equal IC time RE prime plus RE. Okay, then you can cancel IC with IC. That will be RE over RE prime plus RE. And RE prime, you know how to find it, and so on. Okay, so let's see the next one. The input impedance, how do you calculate the input impedance? It is the ratio of the input voltage to the input current, and it is calculated as shown. Okay, so what is the input impedance? It is Vn divided by In, or the Vn is Vb, and the current here, this is In. Okay, so actually it is this Rp parallel with the resistance seen by this P, the base. So it is this resistance here parallel with the resistance seen by the base. So how do you calculate this resistance here? It is actually the voltage, or the voltage over the current. So this Zn base, what's Zn base? Equal Vb over Ip. This Vb divided by the input current. This current over this voltage over this current. Okay. So what is Vb? Vb is Ic time these two resistors. This is Vb. And what's Ib? Ib is Ic over beta. Ic over over beta. Okay. So now when you divide them, this will be the answer. Zn base equal beta time Re prime plus Re. Okay. Now the output impedance. What's the output impedance? The output impedance is simply here the impedance seen by the load. So I want to calculate the total impedance between this one and this one. Okay. So here, as I say, this one will be before, this one be open, and this one will be short. When this one is short, this one will be shorted. So you do not have a resistor here. Okay. When this one, if you want to calculate the impedance here. Okay. In the previous one, we don't do that because we need to calculate the impedance between these 2 points. So we do not short this. So we need to calculate the impedance between these 2 points. This is the input impedance. But here, when you calculate the impedance between E and the ground, so this is short. We short this one. Okay, so this will cancel RP. Okay, then the total impedance is what? Is RE. This RE, and this RE prime will be connected to short circuit because, as I said, everything will be shorted here. So it will be RE parallel with RE prime. Why? Because again, this point will be shorted here because the source will be shorted. Once you shorted this one, you shorted RP prime. Okay, then you have everything short here. Okay, so this RE prime and RE, capital E, will be parallel to each other, and this is the output impedance seen by the load. Then let's solve the example. So as I told you before, in the book they have a generator resistance, 50 ohm, for example. Since it's very small, you can neglect it. You don't have to consider it to make it easy. Okay. So now for this design amplifier, the common emitter. This is a common emitter, yes. This is a common collector, sorry. We have to use these 3 equations, 1, 2, 3. Z out, Zn, AV. So we have to prepare all these parameters. Re, we know Re. What's Re in this case? Re is 10K. So this is 10K. So I know this one is 10K. This one is 10K. Okay, what's Re prime? I don't know Re prime, so I have to calculate it using this loop here. Okay, of course, since you don't have a loop because you have another resistor here, then you can calculate the voltage here at this point using voltage divider. Then you have, if you have a 20 volt divided between 22 and 22K, you can assume that the current, the base current, is almost 0. Then in this case, this 20 will be divided equally between 22 and 22. So in the voltage here will be 10 volt. Then if the voltage here is 10 volt, the voltage at this point is also 10 volt. Is 9.3, which is 10 volt minus 0.7. Okay, if this one is 10 volt, the voltage here will be 9.3 because you have almost a diode here. Okay, then now you can calculate the current. The current is 9.3 divided by the resistance, which is 10K. So this will be the current, IC. IC equal 9.3 divided by 10K, which is 0.93 milliampere. And now you can substitute in this equation. So 26 millivolt over 0.93 milliampere, it will be 28. So R prime is 28. But remember, this is 28 ohm. Okay, so 10K parallel with 28 ohm. Then you can calculate the out. Then now you need to calculate Zn. Zn is Rp, this little Rp. What's Rp? Rp, according to this, Rp equal this one here. This is Rp. RB is here. This two parallel with each other now, because you have two resistors. You don't have one. So previous example here, RP. Oh, come on here. RP is this one here. This is RP. Okay, but because in the example I have another resistor like this. Okay, so these two resistors will be parallel to each other. Why? Because the source, the voltage, the VCC will be grounded, will be connected to the ground. Then the one in the top will be parallel with the one in the bottom. Then this will be little RP. Sorry, this one's supposed to be here. So you have a resistor here. So this one parallel with this one will give you RP. So now let's go back to the example. So you have 22 parallel with 22. Then of course this is just 11K. So this RP is 11K. 11 kilo ohm. Okay. Then we need ZN base. We don't know ZN base. ZN base is given by this equation. Beta here is 100. RE prime is 28. We did this already. So we did this one 28. RE, this little RE equal what? Little RE equal RE parallel with RL. We have this in this equation. RE parallel with RL. RE is 10K. RL is 500 or 0.5K. So you can calculate RE. Capital RE equal 0.5 times 10K divided by 0.5 plus 10, which is 10.5. This is a resistance RE. Will be 0.476. So this will be 0.476. Okay, kilo ohm. So now you can calculate the N base and then substitute here to calculate the N. And RE is here also. RE is what? RE is 11. Where's RE? RE is 0.476. Okay. And we have RE prime is 28 ohm. And this is the same like this. Okay, so now I can calculate AV, I can calculate the N, I can calculate the out. So everything can be calculated. So all what you need to look at is these three equations here. So now if you want to calculate the values, for example, Z out equal what? Equal 10K times 0.8. 28 is 0.028. K, 28 ohm is 0.028 ohm. Divided by what? Divided by 10K plus 0.028. Okay. So equal what? Equal 0.027. So actually this is 27 ohm, 0.9 or 28 ohm. So it is almost 28 ohm, which is this number here. Almost 28 ohm. Okay. So you multiply by 1000 to convert it to ohm instead of kilo. So it will be 27.9. So it's almost 28. What about Z in the base? Z in the base is beta times this. So you have 28 ohm plus 0.4. Okay, let's make it in kilo. 0. Okay, let's make it in everything in kilo ohm. 0.028 plus 0.4676. Here it is. This is RE prime plus RE multiplied by beta, which is 100. What's here? What's this? I'm sorry. Again, 0.028 plus 0.476 multiplied by beta, which is 100. And this is 50K. It's almost 50K. So ZN base is 50K, 50.4. Make it parallel with 11. So it is multiplied by, you can store it if you don't want to forget it, time RP, which is 11K divided by the summation, which is 11K plus 15.4, close it. This equal to 9, almost 9K. This is input impedance. Zn is 9K. Then AV, the last one is AV, RE equal what? AV is almost 1 here. If you can't notice that, because RE is much bigger than RE prime. So let's make it here. It is 0.476. Talking about this equation here, this one. AV equal is 0.76 divided by what? Divided by open bracket 28, which is 0.028 plus 0.476 equal 0.944, almost 1. Almost 1. Where is the AV? Yes, here is AV. This is AV. AV is 0.944. Okay. So don't worry about this one here or this one. Just don't worry about this. This is the end, the last one. Okay. Because I neglected this one. Change this number. So this number here. Forget about this part. Next, we'll have some problems, examples similar to the examples that we solved. So this is one is about common base, where we have a voltage here and voltage here. So this one is different from this one. Here's the source, the input is here, the output is here. This is the same, similar. Okay, the output is here also. We just need to calculate VAV, Zn and Z out, and this is the same also. We need to calculate AV, Zn, Z out, and V load, and so on. Okay, and these 3 problems, these 4 problems. So you need to just go through these problems and solve them. The solution is here. You just need to follow the same steps that we solved before. You don't worry about this part here. You don't worry about this part. Okay, so this will be your homework. This part will be your homework. 1, 2, 3, 4. You need to solve them, and the solution is in the handouts. So or in the slides. So please try to solve them first. They are very similar to the problems that I solved. And then after that, compare the answers. And if you have any question, let me know in the live lectures. Thank you very much, and see you in the next chapter if we have any.